Alrighty. So it says, how do we do this? What method do we use to multiply? What do we do when we have parentheses x plus 4 times parentheses x squared minus 6? FOIL. Indeed, that's what we do. Those are called binomials. When we multiply binomials, we will FOIL. How about the red one? If we have x plus 7w in parentheses times the quantity y minus 12xz, how do you do that? Looks really complicated. What do? You FOIL. Yeah, it's a binomial and it's a binomial. You FOIL. That's what you do. I'm not sure if this is brown or purple or what that is. But it says, what method do you suppose we should use to multiply 4 plus 2 square roots of 2 times 5 plus 4 square roots of 2? FOIL. Two terms. Binomials. So a big part of what we're going to do today is just FOILing. Lots of FOILing to get through things. So it says, multiplying binomial radical expressions, what is the product of each radical expression? All right. Well, this is a term and this is a term. That's two terms, that makes it a binomial. This is a term and this is a term. Two terms, binomial. Terms are separated by addition. That's how we know terms. So 4 plus 2 square roots of 2 times 5 plus 4 square roots of 2. Said FOIL. First times first. 20. Outside times outside. Oh, early in this chapter we learned how to do that. You just multiply the integers together and slap the radical behind it. So 4 times 4 is 16. 16 square roots of 2. Inside times inside. 2 square roots of 2 times 5 is 10 square roots of 2. Last times last. Integers times integers. Radicals times radicals. 2 times 4 is 8. Square root of 2 times the square root of 2. And yeah, I'm going to write that as the square root of 4 even though we know it's 2 because I want to make sure people can follow the notes. They're gone. And you know you're done when you have FOIL guy. Really, FOIL is just a fancy little mnemonic device to get us to multiply everything in the first set of parentheses times everything in the second set of parentheses. Well, now we're going to go back and simplify. Let's see, 20, that's about as simple as that gets. But in the middle there, I've got some like terms I can combine. 16 square roots of 2 and 10 square roots of 2 is 26 square roots of 2. And 8 times square root of 4, that's silly because that's a 2. So that's 16. And now I can put the 20 and the 16 together and get 36 plus 26 square roots of 2. So there is our answer, as simple as it gets. So we have one that has a square root of 2 and another one that doesn't. If you were on a tape, Jesse, you could probably just go down to the office and say, this is here, and some tape that show you where the difference is. Alrighty. B. How do you suppose we're going to do that? Do you not know? How do we do this? FOIL. FOIL. First times first, 15. Outside times outside, ooh, one's a radical and one's not. Big deal. Just write it as 3 square roots of 7. Inside times inside, minus 5 square roots of 7. Last times last, minus the square root of 49. We do some simplifying. 15, 3 square roots of 7 minus 5 square roots of 7 is minus 2 square roots of 7. We know that the square root of 49 is 7. Then we say, well, 15 is an integer. 15 minus 7, that's 8. 8 minus 2 square roots of 7. So it's FOIL, but it's kind of FOIL on steroids because we got a lot to keep track of. You know, there's a lot going on here. There's a fabulous looking little got-it for you while I get you a pen partner. So please go after that one. And that is typically how we write them. If you think back to how we wrote complex numbers, the real number part, the pretty stuff was in the front and the imaginary stuff was in the back. We do that same thing with radicals, mostly because sometimes when students are first working with radicals, they'll do goofy stuff like they'll mean the square root of 15 with an x behind it, but they'll accidentally do that, and then we have to take points off, because you don't have everything straightened out right. So if you write it like this, then we know exactly what you mean. So that's why we always put that radical piece in the back like that, just kind of to say, hey, let's not make any mistakes, make it very obvious what it is we're doing back there. Well, that went rather well, I thought. Conjugates. I've heard of that before, but it was when we were working with imaginary numbers. No fair. Chapter 6 not supposed to have imaginary numbers. It's not just complex conjugates. It's not just for imaginary numbers. Conjugates can be done with anything. So with conjugates, we look at the square root of a plus the square root of b. If, for instance, say it were in a denominator, we couldn't leave that there because this has radicals in it. So we say, well, how do you get rid of that? Well, you multiply by the conjugate. Because if we take the square root of a plus the square root of b times its conjugate, oops, apparently that was magically a 5 somehow in my brain. First times first is going to give us the square root of a squared, which is a. Outside times outside is going to be a negative square root of ab, but inside times inside is going to be a positive square root of ab. So we didn't even bother doing the O and I part of FOIL. Last times last would be a negative square root of b squared, which is a b. No more radicals. Great use for conjugates. Great use. So when a and b are rational numbers, then the product of the two radical conjugates is a rational number. Rational number means a number we can write as a fraction. More importantly, for us, it's probably going to be an integer number, which would be very nice. You know, getting back to nice integers instead of having so many ending up with radicals and that kind of stuff. So down here it says, what is the product of these two? And unless I didn't read the header, I hate it when they give away the punchline. So I look at these two and I analyze it and I say, wait a second, 5 and square root of 7, 5 square root of 7, they have exactly the same two terms. The only difference is one is minus and one is plus. Hey, those are conjugates. They just saved me some time. Because I don't have to do FOIL. I'm just going to do foo. I don't need outside times outside and inside times inside. So first times first is 25. And then last times last will be minus the square root of 49. And in our heads we go, oh, I can't believe she wrote down the square root of 49. We all know that's 7. And away we go. So we had two binomials that each had a radical in them. But by using conjugates, we get back to nice integer numbers. And that's what we want to happen. So there are two of them for you and your partner. Go after 5A and B. See what one's answers you get. Those and check in with your partner. Make sure things are going well. Oops.
Yeah, I got it. Yeah. Yeah.
All right, so as I walk around the room, it looks like 5A should be 56. I lie. It was not 56. What is the answer for A? 4. Did B make you think you did something wrong? Oh, too basic. What do you get? Didn't do anything wrong. Boy, I hope we have lots of those in our assignment. Well, no, not lots. Because we're not done with the conjugates. You know, the whole reason we do the conjugates is to get rid of radicals. And when do we have to get rid of radicals? When they're in the denominator. So, sometimes we have a denominator that is the sum or difference that involves those radical expressions. All we're going to have to do is think conjugates, conjugates, conjugates. You can rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. Oh my gosh, that's a lot of fraction talk. Focus on the denominator. Find the conjugate of the denominator and then build your fractions from there. So, away we go. How could we possibly write this expression with a rationalized denominator? Well, we got to get rid of that square root of 5 and that square root of 2. We just saw how you do that. We'll multiply by the conjugate. But you can't just multiply the bottom of a fraction by something. You're changing the answer. If we're going to keep it equivalent, whatever we do to the bottom, we have to do to the top. Have to. It's a rule. Because what we're really multiplying by here is 1. It's going to look a lot different, but we multiplied by 1. So now on the top, we're going to distribute that 3 square roots of 2. And remember, integers are multiplied by other integers, radicals multiplied by the same radical. So these are both square roots. 3 square roots of 10. And we've got a little imaginary 1 in front of that square root of 2. So 3 times 1 is 3. Square root of 2 times the square root of 2. Hey, that's the square root of 4. That's 2. So 3 times 2, that's going to be a 6. On the bottom, not doing FOIL, doing foo. First times first, that's going to be 5. Last times last, hey, square root of 2, square root of 2 is square root of 4, and that's 2. Cool. So now I don't like this in this order, so I'm going to put the 6 up front. And I have that. This time we're not done. Because we have to simplify. Exactly. Is everything on the top up there divisible by 3? No, Cedar Home, not the square root of 10. No, silly. I mean the integers. Because we can divide integers by integers. Radicals, we have to divide by radicals. We don't have a radical in the denominator. We want to divide by 3. Is the 6 divisible by 3? And is the 3 divisible by 3? Yep, we can do that. So 2 plus the square root of 10. Beautiful answer. Much simpler than it. Math is a secret code. Just broke the secret code. This says this. That is cool. Oh, good. There's 2 of them for you. I didn't want you to feel left out. All right. So 6A and B for you and your partner. See what wondrous answers you can expect. If you're stuck, talk to each other. Peek on your partner. It is perfectly legal to do that if they look stuck. I have seen a few papers that have botched the simplifying, so make sure that you check with your partner, see if you botched or they botched. You don't have to arm wrestle over whose answer is right. So negative square root of 21 minus the square root of 35. It looked like some people forgot to divide by a negative when they simplified with that. Next one is not so pretty. So, when you get here, generally people get a little bit uncomfortable because they're like, am I supposed to take this further or not? The answer is yes, we should, because we want something halfway decent out in front. And anything with the radical is going to look ugly anyway. There's just a couple of different ways that we could write this. So 12x divided by 3 would give us 4x. That's the nice part of our answer. But in the back, we could write it as 4x squared to 6 over 3, but you'll find that most books will prefer something like this, 4/3 x square roots of 6. It's just a matter of how easy it is to get it typed into the back of the book when you do that. So we don't usually leave it this way. We usually don't stop there because we like to have something nice and something in the back that's maybe not so nice. So now, part C says we're going to do this problem two different ways. And it is 1 minus the square root of 8 over 2 minus the square root of 8. But here's what you're going to do. You're going to talk to your partner, and you're going to decide who of the two of you is going to simplify the square root of 8 before they do the problem, and which of you will not. And we'll just go after this the way we've been doing it. Because what I need you to see is which one takes more steps. So square root of 8, pretty obviously, square root of 4 and square root of 2. So one of you will change it to 1 minus 2 square roots of 2 over 2 minus 2 square roots of 2 and do the math. And the other one will just say, hey, I'm going to use conjugate right away. And then have a conversation about which one was faster, easier. That's why I'm.
Brain warm-ups and then
Should both get the same answer. It's just that one of these methods is going to take a little longer than the other. Is that the same answer? Which one was not quite done? First one, why isn't the first one quite done? Square root of 8 can be simplified, right? Square root of 8 can be simplified. Square root of 4 and square root of 2. So 2 square roots of 2. And then, of course, the 2 and the 4 can be reduced again. question is, which one is easier? And I did some steps in my head, so you can't just look at how many steps it is. You know, talk to your partner. I mean, is it easier to multiply 2 square roots of 2 by stuff, or is it easier to multiply by the square root of 8? Here's what I always hear when I walk around the room for this. The first is, I like the square root of 8, then I just simplify at the end, and things work out really nicely. I don't feel there's as many steps. And then on the other side, I hear people saying, well, 2 square roots of 2 has smaller numbers, and it's kind of easier to work with smaller numbers than it is to work with that square root of 8. Yes and yes. You know, it is. Overall, I prefer to ignore the simplify when I start and just go with that conjugate right away and simplify at the end. And that's because I feel like if you get radicals mixed in with integers, sometimes people make mistakes when they go through that. But it's a matter of preference. So it's which one you like. Well, this was difficult, but if you think back to what the homework's going to be like, it's going to be more like problem 6 and then the got it A and B. So please 43210 me, not looking at this last question, but the ones before that. How do you feel about our conjugate use today? Well, that looks pretty good. Why don't you thank your partners and head on back. There it is. So we were still using a lot of the skills that we did before when we were working with square roots. But now that we have numbers in it, I don't know, it just feels a little better. You know, for coming up with an actual answer. We had one that also had variables in it here today with the conjugate, and that's more algebra 2-ish, you know, and definitely more pre-calc and college algebra. But you're doing a great job. You're wandering around and you're talking to each other and you're getting them, and if you're not, you're talking with your partner about, hey, this is what got messed up here. Don't feel like you gotta stand there by me. Got me stuck? Thank you.